Hi Flashes! So today we are going to go through your quarter 4 benchmark review, which is your probability review. So, question 1. In a bag of red and blue marbles, the probability of selecting a red marble from a bag is 0.37. Find the probability of selecting a blue marble. Well, as we know, percents or decimals, in this case probability is always out of 100%. So if a red marble, selecting it from the bag, is 0.37 and we need to find the blue marble, all that we need to do is take 1 minus that 0.37, and that will give us our probability. So 1 minus 0.37 gives us 0.63. So in other words, 63%. So you can leave it as 0.63 since they gave us a decimal to begin with, or if you put 63%, that is fine as well. Okay, second one, determine if each event is an independent or dependent event. So I wrote these off to the side to remind us. So independent means that the first probability does not affect the second probability. So no matter what the event is, the first one, it will not affect the probability of the second event. And then vice versa, dependent means that it does affect the probability of the second event. So for number 2A, it says a quarter lands heads up and then a nickel lands tails up. So you have a quarter and a nickel. So if you flip the quarter and it lands heads up, is that going to affect the probability if you flip a nickel and then it lands tails? No, it's not going to affect it. Okay, so you flip a quarter and then you flip a nickel, no matter what, both of those probabilities are still 1/2. So this event, since it doesn't affect the second probability, is independent. Alright, and then the second one, a coach randomly selects 2 students to demonstrate a drill. So a coach has all these students and they randomly select 2 students, and when you select the first student, then you don't have, so when the coach selects the first student, that means that when he goes to select the second student, he has 1 less student to choose from. So the first probability is going to affect the second probability, since there is going to be 1 less student to choose from. Because after the coach selects that first student cannot be picked again. So when you go to select a second student, that means that you have 1 less student to choose from, which will affect your probability. So if it is going to affect, then it will be dependent. Alright, number 3, determine whether the event is mutually exclusive or not mutually exclusive. So a magazine contains 12 pages. You open to a random page and the page number is a 2 or a 9. So mutually exclusive means that it cannot happen at the same time. Not mutually exclusive means that it can happen at the same time. So if you are reading a magazine and you flip it open to a random page, if you open it to page 2, can page 2 be the same as page 9? Can page 9 be the same as page 2? No, those are 2 completely different pages, so they cannot happen at the same time, which means that it is mutually exclusive. Alright, number 4, find the probability of selecting a yellow jelly bean from a bag with 3 blue jelly beans, 8 yellow jelly beans, 7 beans. So, if they want us to find the probability of selecting a yellow one, we need to first figure out how many yellow jelly beans are in the bag. Well, they tell us right here that there's 8 yellow jelly beans in the bag. And then it always is going to be out of how many there are total in the bag. So just add up all the jelly beans. 3 plus 8 plus 7 plus 2, and that gives us 20, so 8 out of 20. However, if you look at our answer choices, we don't have an 8 out of 20, and that's because this can be reduced. So just think of a number that goes into both 8 and 20, and right away I know that 4 goes into both 8 and 20. So if I take 8 divided by 4, I get 2. And then if I take 20 divided by 4, I get 5. So it looks like, because 2/5 is reduced all the way, so it looks like there may be a typo here. So I believe it should have been probably B, but that one should have just been a 2. So I'll just make a note of this so that we can change it, but it should be 2/5. Alright, number 5. Dana has 9 green chocolate candies, 19 red chocolate candies, and 14 yellow chocolate candies in a bag. She randomly pulls a chocolate candy from the bag, eats it, and then pulls out another candy. What's the probability that Dana selects a green candy and then a yellow candy? So, first thing that they want us to do is find the probability of the green candy. So, you have to figure out how many green chocolate candies are there. So we need to figure out how many green chocolate candies there are. So it says right here that there are 9. And again, it's out of how many we have total. So you just add 9 plus 19 plus 14. And that gives us 42. So there's 9 out of 42 green chocolate candies. Then she is going to eat it. So if she eats it, that means that we have one less chocolate candy to choose from. So I know for sure that in my next probability, when I'm selecting a yellow candy, that if I have one less chocolate candy, then this 42 total now turns into 41 since she ate the previous one. And then she ate a green one, so now we just need to figure out how many yellow we have. So we just go back up here, and she still has 14 yellow candies. So all that we need to do is multiply our two probabilities together. So I'm going to use my calculator here, because my calculator will always reduce my fractions for me. If you like to do it by hand, you're more than welcome to, but I just like to use my calculator because, like I said, it already reduces my fractions. So I'm going to have 9 over 42 times 14 out of 41, and it reduced it all the way down for me to 3 over 41, and if you notice, that is answer choice D. Alright, number 6. In a game of checkers, there are 12 red game pieces and 12 black game pieces. Julia is setting up the board to begin playing. Find the probability that the first 2 checkers she pulls from the box without replacing the first checker will both be black checkers. Determine if this is an independent or dependent event. So again, independent is when it doesn't affect the probability, and dependent is when it does affect the probability. And the thing that you guys need to notice by now is whenever it says the word without replacing or replacing, because that is your indicator on right away if it's going to be independent or dependent, because if she does not replace the checker piece, that means that she has one less checker piece to choose from. So if she has one less checker piece to choose from, just like up here with the chocolate candies, then it's going to affect the second probability. So that means that it's a dependent event because it does affect the second probability. Alright, and then number 7, in a game of checkers, there are 12 red game pieces and 12 black game pieces. Julia is setting up the board to begin playing. Find the probability that the first 2 checkers she pulls from the box without replacing the first checker will both be black. So, start with the first probability of finding a black checker piece. So it says that there are 12 black game pieces out of Looks like 24 total. But then when you go to select your second black piece, you have to assume that you chose a black piece the first time. So if you chose a black piece the first time and you're not replacing it back into the box, that means that you have from. So we don't have 12 black pieces again, we now have 11 because we did not put that other one back into the box. And same thing for our total down here. If we didn't put the first black piece back into the box, then when we go to select our second black piece, we have one less to choose from. So if we have one less, that means that we have 23 game pieces to choose from. So just multiply that together, and I'm going to use my calculator again. And I got 11 out of 46. Alright, so as you guys know, you can pause this video at any time and let me know when you are ready to keep moving on. Okay, now on to the second page. So number 8, in a game of checkers, there are 12 red game pieces and 12 black game pieces. Explain replaced, and then a black checker is drawn. State the correct probability in your answer. Use complete sentences and correct mathematics vocabulary. So this first sentence, this is a blank event. They're wanting to know if this is independent or dependent. So just like I said on the back page, as soon as you see that word replaced or without replace, that's your indicator on what kind of event it is. So if you do replace the black checker back into the box, then this is going to be an independent event because the check was replaced. So that means that it was put back, which means that it's not going to affect your second probability. So then they just want you to find the probability. So if you were to draw a black checker piece, there's 12 of them out of 24 total. And then if you replace it back into the box, then you still have the 12 black checker pieces out of 24 total. So if you were to multiply those together, so 12 out of 24 times 12 out of 24, we get 1/4. So that is the probability. So 1/4. Okay, so 2 socks are drawn from a drawer which contains 2 red socks, 1 blue sock, 3 black socks, and 4 green socks. Once a sock is selected, it is not replaced. Find each probability. Okay, so let's go to number 9 and figure out what's the probability of getting a red sock and then a black sock. So first thing that we see here is a red sock, so we need the probability of getting a red sock. So it said that there are 2 red socks out of how many total? Well, there's 2 plus 1 is 3 plus 3 is 6 and plus 4 is 10. So that means that we got 2 out of 10 for getting the probability of getting a red sock. And then if we want to get a black sock, it says that the sock that we selected before is not replaced. So if it's not replaced, that means that we have 1 less sock in there. So if we have 1 less sock, we started with 10, but now we only have 9. So then we need the probability of getting a black sock, and it said that there are 3 black socks. And then we can just multiply those together. So again, you can multiply across, or if you use your calculator, it should reduce your fraction for you. So that's what I like to do. So I get 1 out of 15. Okay, next one is getting the probability of 2 green socks. So if we want 2 green socks, again, we need to find the probability of getting the first green sock. So it says that there are 4 green socks out of 10 total. But once again, once you get a sock, you do not replace it. So if you do not replace it, that means that you have one less. And then, since we selected a green sock the first time, and we are not replacing it back in the bag, or in the drawer, that means that we still have one less green sock. So we started with 4, but we picked a green sock the first time, and we're not replacing it, so that means that I need to take 1 minus 4 to get 3. Okay, so once again, I can go ahead and type this in my calculator, and we get 2/15. Alright, next one. There are 5 quarters, 2 dimes, and 13 pennies in a bag. Once a coin is drawn from a bag, it is replaced. If 2 coins are drawn at random, find each probability. So first one is the probability of getting 2 quarters. So the probability of getting 1 quarter is there are 5 quarters out of, it looks like 5 plus 2 plus 13, which would give us 20. So we have a 5 out of 20 chance to get a quarter the first time. And then if we want to get a quarter the second time, since we are replacing quarters back into the bag, that means that we are still going to have all 20 quarters in there, as well as all 5 quarters again. Since the first quarter that we got, we are putting it back in the bag, and then we can select it again. So we're going to have the same probability because these are independent events. So just multiply those 2 probabilities together. And you should get 1 out of 16. Alright, and then the next one, probability of getting a dime and then a penny. So it says that there were 2 dimes out of 20 total. So 2 out of 20. And then getting a penny, since we are putting this dime back into the bag, that means that we still have all 20 coins in there. And then we still have all 13 of those pennies. So just multiply those. So 2 over 20 times 13 over 20, and we get 13 out of 200. Alright, next one, number 13. At Plenio Ice Cream Shop, there are 2 types of ice cream cones, 8 flavors of homemade ice cream, and 6 toppings. How many different choices do you have? So this is the counting principle. So the counting principle, all that we have to do is multiply all of the different choices that we have. We could create a tree diagram, but as you guys know, the counting principle is a tree diagram. So it says that there are 2 types of ice cream cones, 8 flavors of homemade ice cream, and 6 toppings. So all that we need to do is take 2 times 8 times 6. And we get 96 different choices. So our answer is D. Okay, 14. Deanna separates her Skittles from her M&Ms. For each type of candy, she has 9 red candies, 4 green candies, and 7 yellow candies, and 5 orange candies. Are the events of drawing red Skittle and an orange M&M dependent or independent events, and explain. So remember, independent is when whatever you do the first time is not going to affect the probability of the second outcome. So since she said that she separates her Skittles from her M&Ms, that means whenever she selects a Skittle and then an M&M, her probabilities are not going to change because she separated them. If it said that she didn't separate them, then that would change the probability of getting an M&M because that would be one less candy to choose from. But because she separated it, that means that this will be an independent event. sorry, I gotta move up my paper here. So this is an independent event because the red Skittle and orange M&Ms were drawn from separate bags. So they were drawn from separate bags. So now we just need to find the probability. So the probability of getting a red Skittle, it said that she had 9 red Skittles out of, let me add up all these candies, so 9 plus 4 plus 7 plus 5 gives us 25. So she had 9 red candies out of 25 total. Then, if she wanted to select an orange candy, it said that she had 25 of each type of candy, and then she had 5 orange candies. So when we multiply those together, that's 9 over 25. Oh, I gotta put it in my calculator correctly. 9 over 25 times 5 over 25. And we get 9 out of 125. Again, pause the video if you need for it to be paused. Otherwise, I'm going to keep moving on. Alright, number 15. From the tree diagram, ice cream options are shown in the table. How many possible outcomes are vanilla? So if you notice, we have our first option is picking a cone or a cup. Then you can choose, looks like the type of ice cream, so vanilla or chocolate, and then the different toppings that you have. So they just want to know how many different possible outcomes are vanilla. So you only have to look at your vanilla choices. So what I have circled are your vanilla choices. So you just need to figure out all the different outcomes that you can have with vanilla. So you can have vanilla ice cream with sprinkles, vanilla ice cream with nuts, or vanilla ice cream with strawberries. Or again, you can have the vanilla with sprinkles, nuts, or strawberries. The only thing that's different is one would be a cone and one would be a cup. But you still need to list all the different vanilla outcomes that we have. So we have 1, 2, 3, 4, 5, 6. So there's 6 different vanilla outcomes. Okay, number 16. From the tree diagram, ice cream options are shown in the table. What operation could you use to find the possible number of outcomes using the counting principle? So remember, the counting principle is when you're taking the number of different outcomes, so like this would be 2, 2, and 3, and all that you would do is multiply them together. So the counting principle, you are multiplying. Okay, next one. What's the probability of you selecting a cup, chocolate, and sprinkles, and your friend selecting a cone, vanilla, and nuts? So, first thing that we need to figure out is what's the probability of selecting a cup, chocolate, and sprinkles? So, looking at our tree diagram, the only cup, chocolate, sprinkles that we have is 1. There's no other cup, chocolate, sprinkles possibility here. So that probability is 1 out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different possible outcomes that could happen. Then your friend wants to select the cone, vanilla, and nuts. So again, there's only one option that has the cone, vanilla, and nuts in it. So once again, that probability is also 1 out of 12. So all that you need to do is multiply those together and you get 1 out of 144. So that is D. Alright, and then that's it. So if you guys have any questions, please let your teacher know so that we can help you. But make sure you guys study for your test on Monday. Thank you.